Hello and welcome back to Yale Lab. Today we are going to solve a problem that's been frustrating everyone who builds RAG system or real-time RAG assistant. That is, how do you handle data or document that changes every single moment? So here's the thing, vector databases are everywhere today. You embed your documents, you toss them into Python or Weave8, you retrieve your information from it by semantic search, and basically your RAG both works for a while or for some kind of static information like this query. I want to get my daughter more interested in science. What kind of gifts should I get her? So here the science gifts are somehow fixed information that I mentioned, right? But if you're taking care of some human resources information like today Alice gets promoted, yesterday Bob's team goes under audit, and project X needs a new engineer recently. Now your vector database is struggling to taking care of it because it has no idea any of this happens if you don't do the ingestion again throughout the entire documents for every moment it's updated. But even if you do that, the traditional VectorRAG is still struggling here because it flattens everything into embeddings like Alice reported to Bob becomes a bunch of numbers in 1536 dimensional space. It's great for finding similar text, but it's terrible for understanding that Alice cannot join project X because Bob's team is locked during an audit. Some logical relationship like that. So here I recommend a blog post that's posted on FalkorDB, which is a graph database that I will introduce later. But here the post is clearly show us the difference between the VectorRAG and the GraphRAG and what the technical challenges in enterprise generative AI to use the RAG technology. Here you will know that the GraphRAG is totally different. It explicitly encoded relationship instead of the text meaning. For example, Alice reports to Bob. Bob manages the platform team. The platform team status is under audit. These are not embeddings. These are actual connections the database can traverse in milliseconds only. These are actual connections the database can traverse in milliseconds only. Especially for the multi-hop reasoning structure, the GraphRAG has clearly an advantage and less constraints. Here you will see the number tell the story, right? The VectorRAG requires O of n re-embedding when data changes. For the GraphRAG, incremental edge updates only. So the VectorRAG struggles with multi-hop reasoning for sure. It degrades exponentially beyond 2 or 3 logic hops. For the GraphRAG, path-based traversal with no accuracy loss. The VectorRAG can't handle temporal context, but the GraphRAG tracks when facts are valid with explicit timestamps. Here, the blog post gives a very comprehensive comparison in query performance and latency optimization to give you an idea what's the benefits that you can gain from the GraphRAG for certain cases, and also including other category of the comparison. So today I will show you how to build a real-time voice agent using GraphRAG. We will use FalkorDB, which is a graph database accelerated by sparse metrics and linear algebra, and Graphiti, which is a temporal knowledge graph framework designed for dynamic environments. At the end of this video, you will have a working agent that can answer complex organizational queries like find me a front-end expert who is not on Bob's team because they are under audit in milliseconds with full temporal awareness. So before we get started, you will need Docker, Python, and a Gemini API key. If you want to follow along, the full source code is in the description. So, alright, let's get started. So let's first see what the data that we have already. So this is the UI front end to look at our graph database set up by FalkorDB. This graph represents a fictional tech company called TechNova with 15 employees set up in this entity cycles and 4 teams and the capabilities they have and the compliance rules included and their relationship between the people report line and the capability they have and also the connection of their team and projects independently. So basically this is the main content of our backend graph database called Talent Graph I set up previously. If you want to know the detail, you will see there is Sarah represents the CTO and 2 VP report to her, and with the engineering VP there are 2 managers. One is Bob, the other is James, who have several reporters with different project responsibility and their competencies included. So now we are going to use the Google's ADK framework to manage the voice interaction and 2 core process to validate our demo to work upon the graph database. Let me start the microphone interaction. Hey, tell me about Alice. Who is her manager and what projects is she working on?
Alice Johnson reports to Bob Thompson, and she is currently working on Project X, where she is the technical lead for Tom Anderson.
And how about Tom Anderson?
Tom Anderson's manager is James Wilson, and he is currently on Project X. Alice Johnson is the technical lead for him on that project. He also has expertise in Spring Boot, Java, and PostgreSQL, and is AWS certified.
So simply look back into the graph, you will see Alice Johnson is here and she has the relationship with the Project X and also has a relationship lines to Bob Thompson, which is her manager right now. So let's try to make some updates for Alice Johnson to see how quick and convenient that the graph will be changed accordingly. Hey, listen, Alice is now promoted to director, now reports to CTO and moved from the Project X to AI strategy project.
Got it. I've updated Harris's information in the knowledge graph to reflect his promotion to director, his new reporting line to the CTO, and his move to the AI strategy project.
Okay, so now let's look into the graph. Let's refresh the graph. Let's find out Alice Johnson is here right now. Can you update me again of her manager with his name and also the project name?
Alice Johnson's current manager is Sarah Chen, the CTO, and she is working on the AI strategy project. Is there anything else I can help you with regarding Alice?
Hey, I give you a new task. You need to find a front-end expert to be joining in the Project X who must not be from Bob's team and who must not have worked on any previous AI projects.
Based on the information, Alex Chen is a front-end expert, but they have worked on the AI strategy project. Maria Garcia is a front-end expert and not on Bob's team. There is no indication that Maria has worked on any AI projects. Therefore, Maria Garcia seems like a suitable candidate for Project X.
So let's look back to the database to see Maria Garcia. So you can see here is Maria Garcia, who belongs to the front-end team and report to Sophie Martinez, and it has no relationship with the AI projects, like AI strategy projects so far. right? So this is good, right? It's easier and quickly to find a correct nodes and its relationship between a complex logical nets. So for this example, we are using a quite small graph that cannot fully expose the capability and advantage of graph search, but multi-hop reasoning with such logic is good enough to prove that GraphRAG is much better than VectorRAG in these cases. It just follows the edges and nodes to find out the target information that we want to have. So here is our foundation of this project, which is FalkorDB. It's an ultra-fast multi-tenant graph database. Unlike traditional graph database, FalkorDB uses sparse metrics to represent the adjacency matrix and linear algebra for queries. It makes graph algorithm blasting fast. So that's it. To set up this database in your server, it's quite simple. If you have Docker installed, just run the Docker command here. It will automatically deploy a FalkorDB instance for you to access. So once you run this command, you can directly visit it in your browser localhost port 3000, just like this. Okay, so FalkorDB also provides Python client to let you to use Python on the query language. So this is the simple code that I copy paste from its document for a quick test. So you can run. It quickly goes up for the two queries, which rider represents Yamaha, which is Valentino Rossi, and how many riders represent Team Ducati. There's one rider. Okay, so this is a quite simple DB query. How we add AI model on the top of it to run our human language search is the capability provided by Graphiti. So when I initialize this graph, I haven't using the DB query language to create nodes and edges one by one. I actually built this organization by natural language. That is by using Graphiti. So all this structured knowledge graph has been processed from a human language to become a final organized knowledge graph. So I will not go deeper of Graphiti. You can look at its GitHub repository by yourself to understand what's the backend working on graph. By looking at the code of setup graph, you will see the patterns. Okay, so this is a very typical patterns for one episode. We have the content that's a plain language to mention the entire architecture and some people, some reporting line, and other things like the project team and capability and anything that you want to include it. And also the type. If you are mentioning in a text, in a plain text, you just use the episode type with text, and also it supports JSON or other structured data you are going to involve, and the description of it. And you should notice that there is a timestamp, which is extremely important for this framework. This is the key because Graphiti tracks when facts are valid. When Alice gets promoted later, it doesn't delete the old edge. It marks invalid at a certain timestamp when you add a new episode to update the Alice status and create a new edge based on your new episode with a valid timestamp. And for the initialization, I created 8 episodes to set up the graph you have seen, and also add this episode to Graphiti one by one by put the corresponding information into the certain field, like name, episode body, which is our content, and the source. We provide the type and the source description, and also the reference time we insert with our timestamp. Okay, that's the initialization or adding process of a graph database by using Graphiti. And also you need to link your database into the Graphiti. Here we use the Falco database, so we have to initialize the Falco driver into the Graphiti by provide our Falco post and port and also the database name. And also you need to provide the LLM to support the understanding of your human language. Here I just use the Gemini 2.0 Flash and can definitely use a more advanced model to make the adding process more concisely. So let's talk about the final agent that actually working from the demo to perform the human interaction and the backend graph updates and retrieval. Here is our process. You will see when the user give voice, ADK frontend get that and send to the Gemini 2.5 agent we have created in the backend. And there are tool called search HR information that will called by the Gemini agent when the agent think that the user's voice query is related to the graph information. And now the search HR information tool is not directly do the Graphiti interaction. It will use the LLM to generate subqueries, and these subqueries parallelly do the graph search in FalkorDB via Graphiti, and the duplicated facts will be provided in several lists and format and return to the Gemini agent, and Gemini agent will use these facts and perform its final voice response based on the user's query. So here you will notice that we add additional steps to generate subqueries because the user don't ask graph-friendly queries. They say things like who is available for project X, but what does the available mean? Not already on project, has the right security clearance, and a single graph search can't handle this ambiguity. You need to decompose this into multiple targeted queries and run them and then combine the results. So our solution here is let the LLM to decide which and how many search queries need to be set up to send to the Graphiti into the graph database dynamically. So the actual real-time agent in our demo, we provide its implementation into the folder HR agent, and under that folder there's an agent.py file to contain all the code that define the agent. We use that structure because we want to use the ADK framework to let the ADK to provide the UI front end, including voice interaction, text interaction, and debug printouts for the agent behavior and tool call process. So in this agent implementation, there are two tools that we have provided by setting up the Graphiti instance and connected the instance to model and to the FalkorDB. The first tool is add HR information function, which is a real-time updates with temporal tracking. Basically, the agent will call this tool when the user provides new information about the several items provided here, including employee details, organization details, the project changes and team changes, and compliance and policy updates. The implementation here is quite simple. Just add a new episode with the content, which is actually the user's query in plain text, and provide it with a UTC time stamp to the reference time. Then the second tool is search HR information, which we have mentioned before, is the search tool for the HR knowledge graph for information. So this tool performs an intelligent multi-step search to retrieve HR information by any of the contents here. And the key is we ask a tool to automatically break down complex queries into multiple target search. So there is an internal function generate search queries by calling the Gemini model 2.5 Pro to generate a list of search queries. So here we use a Pydantic object search queries to guide the model to provide structured output to simplify our process for this response list. So the Pydantic model here is very simple, just including one field queries, which is a list of the text query that generates by the model. When get that list of query, it will go on for a parallel execution for these query tasks because we want to reduce the time by call the backend graph database. And both Graphiti and the Falko database support parallel execution. to reduce the processing time. And we get the response from the Graphiti, which actually couple of lists with the facts that are retrieved from the graph. And this tool will append all these facts, the valid time and invalid time, with the query put together and return it to the speech model to let the speech model to do the filtering and summarization. And here is the agent, which using the Gemini 2.5 Flash native audio preview model to do the real-time voice interaction. And also you can choose Gemini 2.5 Flash or 3 Pro to do the text interaction instead. And here we guide the model to select either add HR information tool to add a new relationship or new information into the graph database, or search HR information if the user wants to know something about this organization. So that's it. From this agent and the tools, we can simply extend it to more complex relationship domain like supply chains, more complicated organization charts or social networks. Also, we can do the frequent updates based on the state changes and other transactions that we want to update into the graphs and reflect into the model's response immediately. So that's all for this agent definition, and there is no need for other processing implementation above the agent because all is handled by the ADK framework. So if you want to run the agent under ADK, you just move to the root folder and then run ADK web command. And you will see that its ADK UI has been available on port 8000. When you move to the 8000 localhost, you will find there's already an agent development kit. UI has been working. So you can either try to use a microphone to do the voice interaction or change the model to text generation model to do the text interaction to the agent about the graph of the HR information. That's all for today. If you have further questions or ideas, please drop them in the comments below. Thanks for watching. I'll see you in the next video.